Hello. Hello and welcome to this video. In this video, we will go through section 9.9 array functions and operators, and likely we will finish this section. I know that I have not shown any examples of conditional expressions, and I will not be showing array functions and operators example today. Both the sections examples will be covered tomorrow because I did not get time to prepare the examples. So sorry about that, and please wait for tomorrow. I will show you the example of section 9.18 and 9.19 both in one SQL file. So without further ado, let's get started. Table 9.56 shows the specialized operators available for array types. In addition to those, the usual comparison operators from in table 9.1 are available for arrays. Let me see if sound is getting recorded. Yeah. The comparison operators compare the array contents element by element using the default B-tree comparison function for the element data type and sort based on the first difference. In multidimensional arrays, the elements are weighted in row major order. Last subscript varies most rapidly. If the contents of two arrays are equal but the dimensionality is different, the first difference in the dimensionality information determines the sort order. So first we have our operators. This operator is at the rate greater than compares two arrays. Does the first array contain the second? That is, does each element appearing in the second array equal to second element of the first array? Duplicates are not treated specially, thus array 1 and array 1, 1 are considered to contain the other. Any array less than at the rate any array returns a boolean is the first array contained by the second. So for example, array 2 to 7 is it contained by the second 1, 7, 4 to 6. So we see 2 and 7 are contained, so it is true. Any array and any array, do the arrays overlap? That is having any element in common. So 1, 4, 3 and 2, 1 is common. So yeah. Any compatible array, any compatible array gives any compatible array, concatenates the two arrays. Concatenating the null or empty array is a no-op. Otherwise, the arrays must have the same number of dimensions illustrated by the first example, or differ in number of dimensions by one as illustrated by second. If the arrays are of identical element types, they will be first to a common type. So 1, 4, 3, 5, 4, 5, 6, 7 concatenated becomes 1, 2, 3, 4, 5, 6, 7. Then we have array 1, 2, 3, and the second one is a two-dimensional array 4, 5, 6, 7, 8, 9.9. So the arrays become 1, 2, 3, 4, 5, 6, and 7, 8, 9.9. Any compatible array becomes any compatible array, concatenates an element onto the front of an array, which must be empty or one-dimensional. So 3 when concatenated with array 4, 5, 6 becomes 3, 4, 5, 6. Any compatible array, pipe any compatible, concatenates an element onto the end of array, which must be empty or one-dimensional array. So 4, 5, 6, pipe 7 becomes 4, 5, 6, 7. See section 8.15 for more details about the array operator behavior. See section 11.2 for more details about which operators support indexed operation. We have seen 8.15, and when the time will come, we will look at section 11.2. Table 9.57 shows the functions available for use with array type. See section 8.15 for more information and examples of the use of these functions. We have already gone through section 8.5. So first function is array underscore append any compatible array, any compatible. Returns any compatible array. Appends an element to the end of array, same as the any compatible array, pipe any compatible operator. So suppose the array is 1, 2, and we want to append 3, we do that, and the new array becomes 1, 2, 3. Array cat any compatible array, any compatible array, which is gives us any compatible array. Concatenate two arrays, same as any compatible array, pipe any compatible array operator. So array 1, 2, 3 is concatenated with 4, 5 to get 1, 2, 3, 4, 5. Then we are underscore dims takes an array, returns a text element. Return a text representation of the array's dimension. So array 1, 2, 3 is here. and then 4, 5, 6 is here. So it is basically two-dimensional array. So 1 colon 2 and 1 colon 3. Each element in the outer array is a three-dimensional array, or rather three-element array. Array fill any element, comma integer array, comma optional integer array gives any array. Returns the array filled with copies of the given value having dimensions of the length specified by the second argument. The optional third argument supplies lower bound values for each dimension. So we have any element 11 and array dimension is given as 2 dimension and with 3 element each. So we get 11, 11, 11, 11, 11, 11. Then we have 7 single dimensional 3 element array, and then the lower bound is here, so it becomes 2 colon 4 and the array is 777. Then we have array length, takes any array and integer and gives an integer. Returns the length of the requested array dimension, produces null instead of 0 for empty or missing array dimensions. So we have array 1 to 3 with one dimension, it gives 3. We have array with empty array with one dimension gives null. We have any array with one element text, we get 2 dimension is null. Array lower takes any array comma integer, returns an integer, returns the lower bound of the requested array dimension. So we have the array 0 colon 2, 1 comma 2 comma 3, and we cast it to integer array. And we have the integer 1, which is the lower bound of the requested array dimension, which is 0. Array underscore indents any array integer returns the number of dimensions of the array. So we have a two-dimensional array here with one first being an array of 1 to 3 and the second element is 4, 5, 6. So the dimension is 2. Array underscore position takes any compatible array, comma any compatible, comma integer, returns an integer. Returns the subscript of the first occurrence of the second argument in the array or null if it is not present. If the third argument is given, the search begins at that subscript. The array must be one-dimensional. Comparisons are done using is not distinct from semantics. So it is possible to search for null. So we have Sunday, Monday, Tuesday, Wednesday, that's weekdays. We are looking for Monday. That is at subscript or index 2. So this is one based indexing, okay? Do you remember that? Array underscore position says any compatible array, comma any compatible gives integer array. It returns an array of the subscripts of all occurrences of the second argument in the array with given as first argument. The array must be one-dimensional. Comparisons are done towards the same story. If the value is not found, then an empty array is returned. So we have array A, B, A, and we are looking for A which will be available at dimension at position 1, 2, and 4. Then we have array underscore prepend any compatible, comma any compatible array. Returns an any compatible array. Depends an element to the beginning of an array, same as any compatible pipe, any compatible array operator. So we prepend 1 to array T3 to get to 1 to 3. Array underscore remove any compatible array, comma any compatible, returns any compatible array. Removes all elements given to the value to the given value from the array. The array must be one-dimensional. Comparisons are done using it's the same story. So we have an array of 4 elements 1, 2, 3, 2. We want to remove 2, so we are left with 1, 3. Then we have array replace takes any incompatible array, comma any compatible, comma any compatible, and returns any compatible array. Replaces each array element equal to the second argument with the third argument. So our array is 1, 2, 5, 4. We want to replace 5 with 3. So it becomes 1, 2, 3, 4. Array underscore reverse takes any array, gives any array, reverses the first dimension of the array. So array reverse, we have taken an array with two-dimensional array with 3 elements, and each element is one-dimensional array with 2 elements. So the arrays are 1, 2, 3, 4, 5, 6. And after reverse, it will be 5, 6, 3, 4, and 1, 2. Array underscore sample takes an array and an integer, returns any array. Returns an array of n items randomly selected from array and may not exceed the length of the array's first dimension. If the array is multidimensional, an item is a slice having it given its first subset. So array 1, 2, 3, 4, 5, 6, we want 3 to be selected randomly. The array is selected is 2, 6, 1. Then we have 1, 2, 3, 4, 5, 6. We want to select two elements, 5, 6, and 1, 2 are selected at random. Then we have underscore shuffle, takes any array, returns any array, randomly shuffles the first dimension of the array. So it's trivial, you can look at it. Array underscore sort takes any array, descending or ascending takes a boolean. Now first is boolean. So sorts the first dimension of the array. The sort order is determined by the default sort or ordering of the elements type. However, if the element type is collectible, the coalition to use can be specified by adding collect clause to the array argument. If descending is true, then sort in descending order, otherwise sort in ascending order. If omitted, the default is ascending order. If now first is true, then nulls appear to before non-null values. Otherwise, nulls appear after non-null values. If you remember our querying, which is discussed in first few videos, we did see nulls were coming at the end after non-null values. If omitted, nulls first is taken to have the same value as descendant. So we sort the two-dimensional array. We have this as an example. Array to string takes any array and a delimiter text and now string text. Returns text. Converts each array element to its text representation and concatenates those separated by the delimiter string. If now string is given and not null, then null array entries are represented by that string. Otherwise, they are omitted. See also string to array. So we have 1, 2, 3 null 5 and delimiter is comma and null should be replaced by star. So we get 1, 2, 3 star 5. We have array upper takes any array and integer and returns an integer. Returns the upper bound of the requested array dimension. So we have our array here. So 1837. So for the requested dimension, the upper bound of requested array dimension is 4 because there are 4 elements and we can create 4-dimensional array with 4 elements. Ordinality is any integer takes any array, returns an integer, returns the total number of elements in the array or 0 if the array is empty. So array 1, 2, 3, 4 has 4 elements and it returns 4. Trim array takes any array and integer returns any array. Trims an array by removing the last 10 elements if the array is multidimensional. Only the first dimension is trimmed. So we have array 1, 2, 3, 4, 5, 6. We want to trim 2 elements. We will get 1, 2, 3, 4. Then we have unnest expands an array into a set of rows. The array's elements are read out in storage order. So if we unnest array 1, 2, we will get 1 and 2 in different rows. If we unnest two-dimensional array full bar bars cubes, we get full bar bars cubes. Then we unnest any array, comma any array, and then up element. It gives us set of elements, comma an element, and so on. Expands multiple arrays, possibly of different data types, into a set of rows. If the arrays are not all of the same length, then the scattered ones are parted in nulls. This form is only allowed in queries from clause. So we have select star from unnest array 1 to array full bar bars. So as x, a comma b. So we have two columns A and B, and first element contains 1, 2, the second column contains full bar bars. See also section 9.21 about the aggregate function array underscore aggregate for use with arrays. So we will see that after training multi-range functions and operators. So since we do not have an example or any code to be seen, I will end this video here, and in the next video we will start with range, multi-range functions and operators. But before starting section 9.20, I will present an example for section 9.19 and section 9.18, that is conditional functions and operators and arrays functions and operators. So I hope that you are enjoying this video and you are getting something to learn. So thanks a lot for watching the video. We will meet again tomorrow with another video on PostgreSQL documentation. Till then, have a great day. Stay curious, keep learning, and most importantly, enjoy.